So here we have a nested radical problem and we have to find the value of x. 7 times square root of 7 times square root of 7 all under square root. How do we solve this? Now when a is under square root, it means a is raised to the power of 1 upon 2. So to remove the square root, we square it. When we square it, exponent is multiplied with 2, then this 2 and this 2 gets cancelled. So there are two ways we can solve this. First, we can use the property of square root and then find the value of x, or we can use the identity. So let's first use the method 1. We square both the sides. So we square it, and this side also 49 raised to the power x, we square it. Now this square removes the square root. Now this is 7 times square root of 7 times square root of 7 is equal to 49 raised to the power of 2x. Again we square both the sides. So 49 raised to the power 2x, then whole raised to the power of 2. Now this square is on 7 also, and this square removes this square root. So 7 squared times 7, then square root of 7 is equal to 49 raised to the power of 4x. Again squaring both the sides, we have 7 square times 7, then square root of 7 whole square is equal to 49 raised to the power 4x, then whole raised to the power of 2. This square is now on this 7 and this 7 also, because when a times b whole raised to the power m, this is equal to a raised to the power m times b raised to the power m. Therefore it will be 7 raised to the power of 2 times 2 is 4, then 7 raised to the power of 2, and this square root of 7 raised to the power of 2. This square root removes the square is equal to 49 raised to the power of 4 times 2 is 8x. Now we have 7 raised to the power 4 times 7 raised to the power 2 times 7 is equal to 49. We can write it as 7 raised to the power of 2, then whole raised to the power of 8x. There is an identity. If a raised to the power m times a raised to the power n, this is equal to a raised to the power m plus n, and a raised to the power m whole raised to the power n is equal to a raised to the power m times n. So this will be 7 raised to the power of 16x, and this side we will add the exponents using this identity. So 7 raised to the power of 4 plus 2 plus 1 is equal to 7 raised to the power of 16x. Again, when a raised to the power m is equal to a raised to the power n, and a is not equal to 0 or 1, here a is 7, then m is equal to n. That means 4 plus 2 is 6 plus 1 7 is equal to 16x, or x is equal to 7 upon 16. This is the value of x we are getting. Let's verify this answer. Before verifying, let's use the second method to find the answer, and that will self-verify the answer. If we get the same answer with the second method also, we know that when a is under square root, it is equal to a raised to the power of 1 upon 2. So we can write 7 under square root as 7 raised to the power of 1 upon 2 times this 7 is under this square root and this square root. So 7 is raised to the power of 1 upon 2, then whole raised to the power of 1 upon 2, then times this 7 is raised to the power of this square root and this square root. So 3 square roots. So that 7 raised to the power of 1 upon 2 times 1 upon 2 times 1 upon 2 is equal to 49 as 7 raised to the power of 2, then whole raised to the power of x. So this is 7 raised to the power of 1 upon 2 times 7 raised to the power of 1 upon 4 times 7 raised to the power of 1 upon 8 is equal to 7 raised to the power of 2x. Now we can add the exponents using the identity a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. So 7 raised to the power of 1 upon 2 plus 1 upon 4 plus 1 upon 8 is equal to 7 raised to the power of 2x. Now again we know When a raised to the power m is equal to a raised to the power n, then m is equal to n. That means 2x is equal to 1 upon 2 plus 1 upon 4 plus 1 upon 8, or 2x is equal to LCM of 2, 4 and 8 will be 8. So 4 plus 2 plus 1, or 2x is equal to 7 upon 8, or divide both the sides by 2. So x is equal to 7 upon 16. So we are getting same value for x. So x is 7 upon 16. Which method did you like more? Let me know in the comment section. Thanks for watching.